Okay, to remind you, the correlation coefficient of a set of points tells you two things. One, how strong of a relationship is going on. In other words, how closely do the points form or fit to a line of best fit, right? So how linear are they? Are they a jumbled mess everywhere, or do they fit really tightly into a line? And the second thing it tells you is whether the slope of the line that they're trying to fit is positive or negative. In other words, is there generally an upward trend, or is there generally a downward trend? So here's an example of a possible correlation coefficient. Now this one does not relate to this graph at all. It's just an example of what a correlation coefficient might be. Again, a correlation coefficient is a number between -1 and 1. So it's either a positive correlation, so it's from 0 to 1, or it's a negative correlation between 0 and -1. So the sign of the correlation coefficient tells you the direction, okay? And then the actual absolute value, or the number piece, tells you the strength. Okay? So in this example, for instance, we don't know exactly what the correlation coefficient is, but we know whatever it is, it's positive, okay, because it's generally an upward trend for the points. So part A just says get a collection of points that has a positive correlation coefficient. And this one definitely does. Part B says get a set of points that has a negative correlation coefficient. Again, these points are trend downward, right? If you made a line of best fit, you would imagine it would go like this. And therefore it has a negative correlation coefficient. Again, we don't know exactly what it is, but we know it's negative, whatever it is. Then it says create a set of points that have a positive correlation coefficient that's greater than 0.9. So if we come up here, that's going to be like up here, which means that it's going to be a positive trend and it's going to be a very strong linear relationship. Well, what I've done is I've gone and made a perfect line, right? And when points lie on a perfect line, then the correlation coefficient is exactly 1. So in this case, that's greater than 0.9. It's a perfect fit, so it's all the way up to the right. And the last one, I'm not even sure this is going to work, but it says we want the correlation coefficient to be a -1 greater than -0.6. So when we're up here, we want it to be negative and greater than 0.6. So if 0.6 is here, negative, we want it to be bigger than that. We want it to be up here. So maybe like -0.3. So we want it to have a downward trend, but we want it to be weak. So I thought a line might go through like this, but notice they're not very tight on the line. They're very loose fitting. I don't know if these have a correlation coefficient of the desired amount, so I'm going to check it. So I'm going to go into Stat, Edit. I'm going to delete any data I currently have in there. Put in our data. So I said 1/4, 1/4. Then I've got 4/5. Okay. Then I've got 5/1. And then I've got 8/3. Good. And now I'm going to go to Stat, Calc, LinReg, hit enter. I've got my diagnostics on, and I see that the R value is -0.37186, so we've done it. This particular set of points has a negative correlation coefficient that is greater than 0.6. In fact, it's -0.37, etc. So there we have it. There's an infinite number of possibilities for this, though. In fact, for all of them. But there's one example.